Dear students, today I shall discuss the effect of temperature on rate of reaction. That is, effect of temperature, effect of temperature on rate of reaction, on rate of reaction. When temperature increases in a reaction, the particles of the reactant, they are getting energy, so the particles are randomly moving in condition, that is, its kinetic energy also increases. That is, the number of particles for collision increases. This number of collision particles, let us consider n. Due to this, at the increase of temperature, the rate of the reaction increases, and this effect is significantly for the reversible reaction. And in the case of exothermic and endothermic reaction, the equilibrium constant will be changed. Let us consider a reaction AB, product P, and amount of heat evolved Q. This is the exothermic reaction. In this case, change of enthalpy is equal to total enthalpy of the product minus total enthalpy of the reactant. Here, its internal energy is high, so that total enthalpy of the reactant is greater, that is, HR is greater than HP, so that it is negative. Its change of enthalpy is negative in the case of endothermic reaction. In the case of endothermic, this is the exothermic reaction. In the case of endothermic AB, product, amount of heat absorbed, that is endothermic reaction, where the amount of heat absorbed for the reaction. In this case, change of enthalpy is equal to total enthalpy of the product minus total enthalpy of the reactant. Here, HP, total enthalpy of the product, is greater than HR, so that it is positive inside, অর্থাৎ change of enthalpy in the case of exothermic endothermic reaction, change of enthalpy is positive. Let us consider a reaction ammonia, nitrogen and hydrogen to form ammonia. This is a reversible reaction. An amount of heat evolved minus 92 kilojoule per mole. In this reaction, in this reversible reaction, change of temperature, then backward reaction, rate of the backward reaction will be increases. That is, amount of ammonia dissociated and amount of nitrogen, hydrogen, that is reactant, will be increases. That is, rate of reaction backward is greater than rate of reaction of forward in the case of exothermic reaction. In the case of endothermic reaction, phosphorus pentachloride is a reversible reaction where phosphorus pentachloride dissociate into phosphorus trichloride and chlorine. Here change of enthalpy is equal to 90 kilojoule per mole. 90 kilojoule per mole. In this case, if temperature increases, then the product of phosphorus trichloride and chlorine also increases. That is, rate of the forward reaction is greater than the rate of backward reaction. And if the temperature is decreases, this will be reverse, both of reaction. And this is the effect of temperature on reaction, rate of reaction in the case of exothermic and endothermic reaction. That is, effect of temperature in the reversible reaction is significantly important. Now, the effect of temperature on the reaction in 1989, Arrhenius first experimentally proved at 10 degree Celsius temperature the rate of the reaction will be double, and he first find out the relation between the rate of the reaction, temperature and rate constant, and the rate of the reaction, in this case rate is directly proportional exponentially EA by RT, where E is the activation energy, R is the molar constant, and T is the absolute temperature. Again, rate of the reaction is directly proportional to the number of molecules which are ready to collision due to the increase of temperature. At the increase of temperature, the number of molecules activated for the collision, and these numbers consider N. That is, overall of this reaction, K into EA divided by RT. that is A, K is equal to this, and this K is equal to dx by dt in the case of 1 mole per liter of the reactant, where A is the temperature coefficient, that is K is equal to A into exponentially A by RT, where x into n equal to A, where the coefficient of temperature. Now we can write